Hey, what's going on, guys? Komegigenzi here. In this video we'll implement a negamax search algorithm for our chess program. So if you're interested, without further ado, let's actually start. Okay, so let's define our search function. So I can say def search and takes the self instance and the search depth as an argument. And as far as this is the recursive function, we need to define the escape condition. So I can say if depth is equal to 0. In this case, I want to return the static evaluation score. So return self dot evaluate. Okay, now let's define the best score variable. It would be equal to minus 10,000. So 10,000 just stands for the minus infinity value. Now let's define the best source and the best target squares. Would be equal to minus 1 at when just initialized. So the idea is to associate the best move with the best score. Okay, now we need to generate the moves. So move list is going to be equal to self dot generate moves. And now here is an interesting trick. So from the move generator tutorial, we remember that if the king has been captured, so this line, so if the king has been captured, in this case we want to return the empty move list. So this is the way, this is the exact way of how we can detect checkmates in our engine. So this is quite a pretty important thing. So we can simply say if not len of the move list, which means that if there are no moves in the move list, in this case we want to return plus infinity, which means that we are in the checkmate or the opponent is in the checkmate, so depending on side to move. Okay, now we want to loop over the moves within the move list. So I can say for move in move list. So if some moves are actually available, so what we do in this case, we want to say self dot make move and pass in the move as an argument. Then we want to say self dot take back and move as an argument. And now the negamax itself, so here we can say simply score equals to minus and self dot search and depth minus 1. So we search recursively, again negating the score and decrementing the depth here. Now the core of the algorithm, so we say, so if score is greater than best score, so this means that for every next move we found a better move. So in this case we want to say best score equals to score. So we do update the best score. So let's say first move, updating the best score, then we go for second move and its score is better, so the best score gets updated. That's pretty it. Now we also need to associate the from score and to score with the current score. So we can say best score, I'm sorry guys, not the best score, best source. What am I doing? So best source equals to move and source, and best target equals to move and target. Okay. And finally, before returning the best score, we actually want to initialize the global best source and the best target squares that we would be using outside of the search. So as soon as we do return the best score, the eventual best score from the move, we need to know what kind of move, which of the root moves is being associated with that sort of a score. So in order to achieve that, we need to say the following: self dot best source. So this is already the global variable from the engine class perspective. So best source equals to this local best source, and self dot best target equals to best target, and we want to return best score. Okay, and now let's test this. So here instead I just want to say, let's say score let's say best, let's call it best score. So best score equals to chess dot search, and let's search depth 3, and okay, I'm sorry, just a bit of a typo. Okay, yeah, okay, so I just need to, sorry guys, just hold on a sec. I just need to disable the print statements within make, move, and take back, because we no longer need them. Okay, unless we will need to debug something, but hopefully not. Okay, and also I want to say, let's say best, let's just print the move. So let's say print, so what can we do? Can we actually use, yeah, we can even use the coordinates to output the move in the human readable format. Even though we're not going to be using this in the eventual version, still this might be interesting, because the bare square indices won't tell much. Okay, so let's say self dot best source and self dot best target. Okay, so now it just prints, sorry, not self, it's chess, it's global. Okay, so chess, and yeah, and now we want to convert this to human readable coordinates. So self dot coordinates indexed by best source, and I'm sorry, it's not self. When I'm using self all of the time, it's chess here. We're outside the class. So chess coordinates and the best target. Okay, and if I did everything properly, now it should output the best move. And we have D2, D4, which is really good. So one last thing to consider is just to say, and nothing there. So here we go. Oh, still, oh, it's not the ends, it's the separator, sorry, separator. Like this. So we have the best move, D2, D4, that was found by our search algorithm. Okay guys, this is it from my side. Thanks for watching. Until the next time, and take care.